Here is another nice example about conservation of angular momentum. We'll have a man, okay, and a plate or platform which can rotate smoothly, okay, about the y-axis. Let us assume this is the y-axis. Initially, the man is not rotating, and he handles a wheel, okay? So initially, the wheel is like this, okay? So the wheel is rotating, but about which axis? About this axis, let me call it x-axis, okay? So the man is on a plate, and the plate can rotate along the y-axis, and he is holding a wheel, and the wheel is rotating about another axis perpendicular to the y-axis, okay? So when it is rotating, the angular momentum is along this axis, x-axis, okay? So because the plate is not rotating and the man is not rotating initially, so L initial, the angular momentum along the y-axis initially is equal to 0, okay? But there is, of course, angular momentum along the x-axis. So I am now focusing on the angular momentum along the y-axis. Then the man will move the wheel such that its axis of rotation is along the y-axis, okay? So now we have some angular momentum along the y-axis. So according to the right-hand rule, it will be at the top. So we started with L initial along the y-axis equal to 0. Now we have some positive angular momentum along the y-axis, and I am standing on the plate, which can smoothly rotate around the y-axis. So what will happen? I started with L initial y equals 0. So L final y should be 0. But I have I wheel multiplied by its omega positive because it is rotating counterclockwise. As a result, to compensate for that, the man and the plate will rotate with omega 2, and omega 2 will be in the clockwise direction, such that the summation of these two angular momenta should be equal to 0. So what will happen? The wheel is rotating counterclockwise. My body and the plate will rotate clockwise to compensate for that and keep the angular momentum along the y-axis equal to 0. So L initial y should be equal to L final y equals 0, and to keep the angular momentum conserved. Because my system, which is me, the plate, and the wheel, there is no external torque is given, and this is why L initial y equals L final y. In a minute, I'll show you this demo. Okay, as you can see, there is opposite rotation. It is rotating counterclockwise, and I am rotating clockwise. Okay, if I reverse it, the opposite will happen. Great, so physics works, my son. This omega for the wheel and omega for me and the plate are opposite in sign to keep the initial and final angular momentum along the y-axis equal to 0. I hope this is exciting for you, as it is for me. Thank you.